station and space to ground.
Welcome to Space to Ground. I'm Sandra Jones. This week, a cargo ship packed with food, fuel, and supplies arrived to the International Space Station, and science research on flames in space continues.
We have engine ignition.
On February 19th, the uncrewed Northrop Grumman CRS-17 Cygnus cargo craft blasted off from Launch Pad 0A at the Wallops Flight Facility in Virginia, carrying 8,300 pounds of science investigations, fresh foods, and cargo. The Cygnus, named the SS Piers Sellers after the late NASA astronaut and climate scientist, arrived to the space station 2 days later. NASA astronaut Rajachari used the Canadarm2 to capture Cygnus, and it was then installed to the Unity module of the space station.
Congratulations to the MCCH and Dulles team and to Northrop Grumman, and welcome aboard again to Piers Sellers. He worked at Goddard and climate science, and it's a daily reminder to us with the experiments on board to help with the climate of the Earth in his name and legacy, and we're happy to be a part of that.
As one important flame study investigation reaches its end, a new one is about to begin. Since 2017, the Advanced Combustion via Microgravity Experiments, or ACME, conducted 6 studies in which 7 gaseous fuels were burned, and over 1,500 flames were ignited and studied. The goal of ACME was to study flammability, improve engine efficiency, and reduce pollutant emission in combustion, as well as to better understand how to prevent fires in spacecraft. Now, the Solid Fuel Ignition and Extinction Facility, or SOFI, builds on the work of ACME with a new series of investigations studying flames in new ways, such as material ignition and suppression. Launched aboard NG-17, SOFI will help NASA select materials and designs for spacesuits, cabins, and habitats. The experiment will also help NASA identify the best ways to put out fires or smolder materials in space. Skin aging may be inevitable, but the unique microgravity environment of space may accelerate the rate of skin aging. A newly arrived study seeks to investigate the underlying molecular mechanisms that drive skin deterioration. The Colgate Skin Aging Investigation arrived on NG-17 and consists of a model that uses human skin cells on a porous membrane to mimic the 3D organization of skin tissue. This study evaluates the cellular and molecular alterations associated with growth in microgravity compared to the normal aging process on Earth. The results from this investigation could help create and validate engineered tissue to protect aging skin, heal from wounds, and combat infection. And that's Space to Ground for this week. Thanks so much for watching. We'll see you next week.